Thank you, Liam. So, yeah, this is a little bit of a story as well. Essentially, I'm just going to give you an overview of some of the direct broadcast products that we're putting into RealEarth and how we're measuring latency in one particular case. So just a little background, which most of you know. RealEarth, its name comes from the concept of real-time data of the Earth. It's a visualization platform developed at SSCC Sims, and it provides satellite imagery and related data products to desktop and mobile browsers. It's built on and driven by open source software, and the purpose is to provide a simple interface for data visualization and comparison across the atmospheric, oceanic, and Earth science domains. Watching Margaret and Scott present makes me realize that maybe we're not making it simple enough, because we have a lot to offer there, and I know that the whole idea is to bring imagery into a visualization system that makes it accessible. So, but anyone who has tried to visualize this wide variety of Earth observation data immediately encounters all these basic challenges of spatial, spectral, and temporal resolution. We have data that is as 5 centimeter spatial resolution to 13 kilometer wrapped smoke. We also have spectral resolution, where we'll have some hyperspectral imagery or a whole stack that we can select which band we want to combine. But the temporal resolution is probably the trickiest, where we have decadal studies and also 1 minute data. So how do you put all that into one interface is pretty complicated. And we use a lot of hardware and software to do that. This is kind of our general architecture. We're up to about 15 servers now running 31 VMs. This is essentially a federation. So we have a head node, which is in orange there, that brings in that is addressed if you just went to realearth.sscc.wis.edu, and then it fans out to the different sources. A lot of the data, a lot of the imagery, when it gets processed into visualization from GeoTIFF to little PNG tiles that come to your browser, it gets cached on those A, B, and C head node VMs. And so there's some real advantages to using RealEarth over other visualization systems, mostly that it's really easy to add new products. It can be pulled or pushed manually or with a cron. We have an upload script. Users can manually or programmatically add any gridded imagery or spatial point line polygon data. I'm saying that's an advantage, but you'll see the asterisk there. It says this is also a disadvantage, and I'll talk a little more about that later. Advantages of RealEarth with direct broadcast and CSPP over other inputs is the low latency, and a direct reception facility could spin up its own virtual machine and immediately have a private or public visualization platform identical to ours, but it wouldn't necessarily have to be part of our federation. And there are quite a few projects that are running their own VMs independently of our federation. So these are some of the VIIRS direct broadcast data that we have in RealEarth. We have the typical true color, false color, day-night band. We have sea surface temperature, active fires. I'm going to focus a little more on the active fires shortly. We also have fire RGB that is coming from CIRA. They get the direct broadcast imagery from us and then create a fire RGB, fire temperature RGB, and a fire temperature RGB 375 meter. Usually it's the M band, but they are sharpening the M band with one of the I band inputs. So You'll notice that we're not getting it from all of the direct broadcast sites that have been referenced here, and it was only, I mean, just yesterday I was asking Mitch, what's wrong with the Miami DB site? And he says, it's fine, and so I guess we're just not getting it from Miami right now, so that's another thing that I'll talk about in a minute. And we also don't pull data from Guam, and I was talking to Scott about that. There's some issues with bandwidth in the, but you know, I don't know what the options are there, and I don't know what products they would be. You know, I don't know if there's an active fire product that would be valuable at Guam, but there might be, and they could use the global one, I suppose. But we also are making a cloud mask and an NDVI right now using modified polar to grid. Most of these, so we ingest geotiffs and to get the gridded net CDF files into geotiffs and correct for the bow tie, we use polar to grid quite a bit, which we really appreciate. It, like Scott says, it's unmatched quality. And I think in the near future, it's going to get a lot more attention as MODIS sunsets. There's a community of land remote sensing people and geospatial scientists like myself that got accustomed to using MODIS because it was such a successful experiment. It began to be treated as if it were operational. And so I think there's going to be kind of withdrawal symptoms and people screaming when they can't get their 250-meter CONUS imagery. So I think there will be an attention to VIIRS, but there won't be the tools that the geospatial community is used to using to correct for the bow tie. And I think polar to grid is going to start showing up in people's search results. But they aren't necessarily going to be able to make what they want with it because of technical reasons. But in the future, hopefully, it'll be a little bit more universal. So here's just some, most of these are really old products in terms of like the development of the workflow to put these into RealEarth. These are, so we mostly have NPP in here, but we can run it on NOAA 20 as well. This is just the true color. Here's the sea surface temperature. Here's them together. Here's, that's not what it's supposed to be. That's supposed to be the false color version, and that's the, gosh, this is disappointing. That's the true color, or the sea surface temperature on the DNB. Here's the DNB with the sea surface temperature. So anyway, these are just some examples. But at this point, you're saying, well, what's the point of this talk, right? Where's the 35-minute thing? Direct broadcast and CSPP really matter to the applications in RealEarth where low latency is essential. And that would be in the case of active fires, I think is probably our best example. So CSPP produces netCDF and text files of VIIRS I-band fire detections, just generated right through and posted with the all the other products that are generated. And even just a couple weeks ago, Jeff Kurian integrated the persistent anomaly flag that had been developed by Yvonne Cesar to note when active fire is actually an oil and gas flare or solar array or an industrial stack or a volcano or something that is not a wildfire, essentially. And that's really a great addition. So, let's see how we do here. Okay. This is the, coming from Gina, this is the fire RGB and the active fires on top of that. And zooming in a little bit, you can see, gosh, it's disappointing. We have a See if the next one's better. No, it's not. I might have to go live and just do it. I was like saying, oh good, I won't bother with the demo because that's unreliable. But looks like screenshots are too. At any rate, we can, wow, just losing my, there we go. Getting a little closer. Okay, so, wow. I think I might just do that actually because that's kind of important information. What this slide back here is supposed to show is the latency measurement that I'm trying to show you. So sorry about that. It's in a pop-up. This is showing that because you're in RealEarth, you can overlay other information. This is a database from the Forest Service telling you the names of the fires. But in this case, that fire that I was pointing at hasn't been documented in the database, which is curated. And so having CSPP and direct broadcast, you can actually monitor fires that haven't been documented well yet. Here's the fire that I was showing earlier. And there underneath it is the fire RGB, so you can kind of see this is kind of a nice example of where those pixels came from that indicated fire. So if you zoom out a bit, you see that, okay, here's a purple one down here, and if you look at the legend, you'll see that that means volcano. We're working on this because sometimes we're noticing they're not always purple, and we're trying to figure out why, but that's new. Okay, this one will work. So what you see here is the pop-up that just has the information from the text file that was posted on the direct broadcast site, translated into what we call it's just GeoJSON being generated, and then a table in HTML has been popped up here. And at the bottom, you'll see there's a latency line there, and the total is 38 minutes. Part of it is a little bit misleading because we're actually fetching this data from Gina instead of Gina pushing it to us, which you can do it either way. And so that first number, 0 minutes, would normally be the time that it took to get the downlink from the satellite to into the processing stream at Gina. And then the second one is is the actual algorithm running and making the product. And then the third one, which is 0 minutes, is when RealEarth actually processes it and puts it into our visualization. And that, so the big part of it is actually just the algorithm running and making the product. The rest of it is just internet traffic that can be seconds, or it's less than a minute. So it's rounded to a minute. So, so there's an example of NOAA 20 detection. 38 minutes later, it shows up in your browser.
You say the algorithm, which algorithm are you talking about? Because a fire algorithm takes seconds.
Yeah, I don't know. I guess it must be the processing to make make level 1, right? It's just signal. It's somehow you got to get the signal to even start the algorithm, right? So it's that part of it. Yeah. So this one, moving down to lower 48, we're looking at. We'll zoom in on this persistent anomaly here that's identified as an oil and gas point, and this one took 53 minutes. So 49 minutes to get the signal into data, 4 minutes to process, and then that's probably more what you would be expecting. And then 0 minutes to actually put it into RealEarth. So we can zoom in on this. And one of the nice things about RealEarth is you can, in the upper left, you can see we have the background map set to satellite, which is the Google Earth satellite map, and it has increasing resolution down to aerial photography. So we'll zoom in on this point, and it starts to get a little bit hard to read when you are zooming in on the 375 meter pixels. This is the Sierra Fire RGB that is made with SIMS, direct broadcast VIIRS imagery. So I turned that off, and now we're seeing the kind of generic base map. But we can zoom in, oops, and zoom in, and zoom in, and zoom in, and keep zooming in. And sure enough, it's starting to look. Now we see that this is WGT gas processing, liquid petroleum. So we're actually, this pixel happens to be pretty well centered. These dots are going to be in the middle of the 375 meter pixel. So it's not always going to line up with your feature, but in this case it really looks like it did. There's a stack here, a smokestack, you can tell by the shadow. So we're getting, we can verify. In fact, at this point I'm starting to wonder if maybe it's the hot sauce on the construction worker sandwich that is creating the anomaly here. But at any rate, so some of the challenges we're facing is that in RealEarth in general, these are general challenges, is that earlier I said that it was an advantage that users can manually or programmatically add any gridded imagery or spatial point polygon data to RealEarth. Well, now we have over 1,000 products. We have 1,608 products, 1,141 are released. Since 2016, we've had 1.13 million unique IPs have come to RealEarth, and we've served over 8.05 billion tiles, which are those little 250 by 250 pixel PNGs. So it's busy. This is just a little scrolling through we have a lot of dashboards to manage all of the VMs and the servers. These are the 31 VMs I mentioned, and they each have a status. And we use this tool to go in and monitor and edit things. Here's just to show you how busy it is. This is one of our public-facing live metrics. I just grabbed a screenshot earlier today for this, and it's or yesterday, Tuesday. This is kind of a leaderboard of the most popular products on the left, and you can see a lot of GOES imagery. And on the right is what people are looking at, what part of the world and how zoomed in, and so the size of the squares based on the zoom level. And so this is kind of interesting. We keep track. When there's a big weather event, things will spike. Certain products become more popular than others. But it's gotten really busy, which is good and bad, right? It's a challenge. Here's another one that more internal one we use. This is showing the different VMs and what products are heading out through the head nodes. And so you can see the GOES one and the lower one is super busy. That's probably where, and that's why you saw on the leaderboard there, they're all going like crazy there. So, so some general solutions. We've tried to, we're a bit overwhelmed with the number of products, and so we've tried this concept of collections and categories, where a collection can represent, like, for example, we have a gridded new caps collection that, like Nadia was referring to, that if you select that collection, then you'll just get the 39 gridded new caps products, and you won't be distracted by all the other stuff that's, in each category, and subset of a collection is a category. Enforcing ownership. So when people actually upload data, they have to register with us, and we want to enforce ownership so that if something goes wrong with the product, we have a point of contact to figure it out, and not just the four of us that work on RealEarth the most. The other part is tutorials and documentation is a big thing that we're trying to improve. And here's like Prob Severe has its own website. Here's the Floods website. And here's where our documentation resides. And I want to thank all these people for supporting this project over the last 11 years. Yeah, you can see the developers. The middle row there is the key Dave Parker, Nick Pearson, Russ Dangle, and Tommy Jasmine. Thank you for your time.